Hello everyone and welcome back to our videos. Today we will talk about the fire detection overheat systems, and I will illustrate the categories of fire detection systems and the types of fire detection systems. First, engine fire detection systems generally fall in two categories: spot detection type systems and continuous loop type system. What's the difference between them? With a spot detection type system, individual fire detectors or switches are used to detect fire. What about the continuous loop type system? This type works on the same basic principle as the spot fire detectors, except that a single switch in the form of a long inconel tube is used instead of several individual switches. That means we will use a continuous loop for make detection for a large area, but the spot it will use more than one for a large area. The small diameter inconel tube is run completely around an engine nozzle or an area that surrounds an auxiliary power unit, thus allowing more complete coverage than spot type detection system. These the two categories of our fire detection systems. Now we will talk about the types or the most common types of fire detection system, and we found in modern aircraft include the first type Venwall, the second type Kidd, the third type Landberg, the fourth type cistern donor, and the last type flame detector system. I will illustrate all the types of fire detection system, and I will start with Venwall systems. The Venwall system produces a thermoswitch fire detection system, a thermocouple fire detection system, and a continuous loop fire detection system. So the Venwall system consists of, or it has, three types. The first type thermoswitch, the second one thermocouple, the third one continuous loop fire detection system. And we will start talking about the thermoswitch detector. The thermoswitch detector, as we see here in this figure, the thermoswitch fire detection system is a spot type detection system. So the thermoswitch is the first category, a spot detection system that uses a number of the thermally activated switches. Each switch or sensor consists of bimetallic thermoswitch that closes when heated to predetermined temperature. Here this the thermoswitch. Here we have the contact point, and here we have the tube. There are two basic types of thermoswitch systems: the single loop and the double loop. As we see here, we have a thermoswitch detector. This thermoswitch detector consists of expansion tube that made of stainless steel and spring bow and the contact point. The contact point is connected to alarming on the cockpit. If a fire starts, As we see here, the switch housing heats up and elongated to close the contact points. As we see here, they will close the contact points. When the contact point will close, they will send a signals to the cockpit for alarming there is a fire. After the heat is released, we will say that the tube it will back to its neutral position, and the contact point they will disconnect from each other, and the alarming will disappear from the cockpit. Now, after we see how the thermo switch will make alarming to the cockpit, we will talk about the first type of the thermo switch detector, and it's the single loop system. With a manual single loop system, all of the thermo switches are wired in parallel with each other, and the entire group of switches is connected in series with indicator light. This the single loop. What about the double loop? The double loop system. In the double loop system, all of the detectors are connected in parallel between two complete loops of wiring. The system is wired so that one leg of the circuit supplies current to the detector, while the other leg serves as a path to ground. The second type of fire detector system is the thermocouple detector. The thermocouple type, or we called Edison fire detector system, is similar to the thermo switch system in that they are both spot type detection system. However, the thermocouple detector initiates a fire warning when the temperature of the surrounding air rises too rapidly, rather than responding to preset temperature as does the thermo switch detector. Here we have a tip of thermocouple. The thermocouple has two conductors made of dissimilar metals welded together at one end to form a junction. When the junction is heated or cooled, an EMF voltage is created, as we see here. A gauge, amplifier, other electronic instrument measures the voltage and display temperature. The thermocouple consists of something called steam, and the steam is made from stainless steel. Inside the stainless steel, we have the two thermocouple conductors with supporting layer made of magnesium. And we have the junction, and our tip can be enclosed or can be exposed. As we see here, if the tip is exposed, it will be faster response time, but it has shorter surface life. But when it is enclosed, of course, you will say that the response, it will be slower, but the surface time, it will be longer. In a typical thermocouple systems, one or more thermocouples are called active thermocouples, are placed in a fire zones around an engine, while a separate thermocouple called reference thermocouple is placed in a dead air space between two insulated blocks. Under normal operation, the temperature of the air surrounding the reference thermocouple and the active thermocouples are relatively even, and no current is produced to activate the warning light. However, when fire occurs, the air temperature around the active thermocouples rises much faster than the reference thermocouple. The difference in temperature produces current in the thermocouple circuit and activates the warning lights and horn. In most thermocouple systems, a sensitive relay and sleeve relay and thermal test unit, they called relay box. A typical relay box can contain from 1 to 8 identical circuits, depending on the number of potential fire zones. The thermocouples control the operation of the relay, while the relays control the warning light. The test switch here that you will find it on the cockpit, when the pilot will switch it, it will give a signal or current that goes to the heater, and this heater will produce the temperature that the thermocouple will sense it and give an electrical signals that will make the sensitive relay to close the switch, and the slave relay will close the another switch and will give us a warning light that indicate the system is work at satisfied manner. This when we make test for our system. Whatever when there is a fire. When there is fire, as we talked, the active thermocouples will sensing that, and the reference thermocouple will sense some about less than the active thermocouples, because the location of the reference thermocouple and between them will make a differentiate sensing that will produce the current that will goes to the sensitive relay and will close the switch, and when the sensitive relay closed, the sleeve relay also will close and will give us a warning light for that there is a fire in the zones that thermocouple is located in.